To nail down the basics of analyzing a rapidly varied flow section, let's first consider the scenario where a hydraulic jump occurs in a steep channel. In this situation, the upstream flow depth is known and the downstream flow depth is unknown. To calculate the downstream conjugate depth of the jump, we use this formula. In order to use this formula, all we need to calculate further is the flow velocity. The flow velocity is simply the flow rate Q divided by the flow area in the channel. And you can find the flow area using the upstream flow depth and the shape of the open channel. If we consider when a hydraulic jump occurs in a mild section, then we know the downstream depth, but we don't know the upstream depth of the jump. Lucky for us, the formula to calculate the upstream depth is similar to the formula used to calculate the downstream depth in the steep channel. The only differences being the subscripts have changed. This means that the channel velocity used in this equation is found by dividing the flow rate in the downstream flow area. The downstream flow area is found by using the channel geometry and the normal depth in the mild channel. In either case, the length of the hydraulic jump can be found using this formula from Hager's book on hydraulic jumps. In case you've forgotten, tan h is the hyperbolic tangent. We can use the conjugate depth formula and a little bit of logic to predict where the hydraulic jump occurs. For example, when we have a steep channel that transitions into a mild channel, we do not know at first if the hydraulic jump will be in the mild channel or the steep channel. To approach answering this question, start by assuming that the jump occurs in the mild channel. For this to be true, the upstream depth must be less than the critical depth. Remember that a hydraulic jump develops when the flow regime transitions from supercritical depth to subcritical depth. In other words, when the flow depth starts below critical and then ends above critical depth. If we calculate the upstream depth of a jump in the mild channel to be greater than the critical depth, then we just proved that the flow was never supercritical. Therefore, no jump can form. If we prove 1 to be false, scenario 1 to be false, then the jump must occur in the steep section. Once we know where the jump is located, we can start analyzing the correct GVF profile length to determine the exact stationing where the jump will occur in the channel.